Good morning, everyone. First of all, I would like to greet all participants and our first presenter, Mr. Raimundas. He is head of Network and Service Infrastructure Department of Poznan Supercomputing and Networking Center.
Thank you. Good morning, everyone. So, dear participants, distinguished guests, thank you for the opportunity to speak at this wonderful conference and present Poznan Supercomputing and Networking Center. I'm stepping in name of our Deputy Director, Krzysztof Kurowski, who sends his apologies and could not participate in this conference due to the other obligations. However, we at PSNC, we are Poznan Supercomputing and Networking Center affiliated with the Institute of Bioorganic Chemistry of the Polish Academy of Sciences, and we have 30 years of delivery of the infrastructure for the research in the region and in the whole country behind us. And I will just give a brief overview of the main projects that we are working in, both infrastructure and research, to foster the innovation, to facilitate the research in whole Poland, but also to use that as a vehicle to drive our own expertise and to increase our own quality, but also innovativeness of what we do. So I will start from the infrastructure, and one of the key elements of this infrastructure of what we do is the high-performance computing. The latest development of our high-performance computing capabilities has been implemented with the Prace Lab project, which is the national Polish contribution to the Prace infrastructure, the European infrastructure for the advanced computing. And that consists of 4 major computing and operational storage sites in Poland and 5 minor sites, which I think that currently all of them have been implemented, and I know for sure that the one in PSNC in Poznan has been implemented, and it provides the next generation computational resources for the scientists, for the physicists, for the biologists, for the bioinformatics, and also it is available, so it's in the order of up to 10 petaflops. That's based on the requirement from the community, and it contains also the operational storage attached to the operational storage. I think that it's a major difference between the Euro HPC sites that are focusing only on compute. And here we focus also in attaching the operational storage so that the data can be stored close to where they are, where the data is processed. Here. However, we have plans for the next iteration of that project into the Prace Lab 2 that will add tenfold capacity of the computational resources. However, I would like to stress a different thing here, that it's not only the raw infrastructure that is foreseen in this Prace Lab 2, because we see that it's already not enough to have the raw computational power. We have to work on the services, and we have to use that capability, that ownership of the infrastructure to further advance the analysis of requirements, but also advance the management, advance the procedures, and the ability of the ease and the accessibility of that infrastructure to the community. So we have HPC as a service, we have GPU as a service. So we move towards the cloud technologies. That's why yesterday, if you have been here, there was an interesting presentation from Mirko Cestare from Cineca, that it was interesting because it's also sort of merging HPC and cloud services, merging HPC capabilities with the availability of the cloud services. I will not talk too much about the applications, but we also see that increasing demand of the computational power from the artificial intelligence development. It's really something that it's been a few years since we see that demand, but the training of the models, all the computational analysis required for the AI and machine learning is very very demanding for the computational resources. We also have addressed the storage needs for archiving the data and for more long-term storage, which is in the whole country is approaching 1 exabyte of the storage capability. But that also is comprised with is complemented with the services that associated with that storage. And as any entity who has access to so much data, we try to benefit from that, to address also to address the volume, to use the volume of the data to perform the research, to innovate further, to advance the services and to innovate further. And that's closer to my heart. The next generation network development project that is currently being implemented with the various layers of network in the different stages of public procurement. That's Pioneer Lab. But as you see here, it's not only the network infrastructure, it's not only the raw capacity, the DWDM, the IP, the routers, but it's the laboratories that use that network infrastructure, that use those technologies to test the new capabilities of the network, to test the new functions, to test the new services of the network. That we at PSNC implement all of the 8 laboratories that are listed here. Other centers, we have 21 center in Poland who implements different set of these laboratories. So we test, for example, we test the new network technologies, we test the new capacity, the new interfaces for the equipment, together with the vendors. We try to advance the network technology to the next level. So the current production network is foreseen to be at 400 gigabits, with the outlook to upgrade to 800 gigabits and terabit capacities in the future once the interfaces are available, because this is a leading edge technology and it's not yet there in the full production environment. You will see today, you will see more probably on this particular project, so I will not spend too much time. We also support digital humanities. And digital humanities means a lot, but it's less infrastructure, it's more on the higher level of services, and it starts with the video production and video and streaming of the video content. We have been cooperating with Giant on streaming the TNC conference, which I would invite you to come to next year. It's a major event, but we also collaborate with the art, with the theater, with the opera, to stream in high quality, to stream the performances, which is increasingly important in the event of pandemic. We also collaborate with the museums, with the archaeologists, to digitize the artifacts, to apply the artificial algorithms to different imaging technologies, to know more, to attain more information from the current physical evidences of historical truth. And as a part of the bioorganic chemistry, we work quite a lot with the bioinformatics, with the healthcare, what we provide is the know-how, expertise, and infrastructure, but also the innovative services, if I might say so, innovative advancements using the ICT technology, using the artificial intelligence, and our infrastructure resources to analyze the data from the science fields, to analyze the data, to produce the therapeutic strategies, to produce the diagnostics, and to facilitate the advancement of the scientific field. That is also, we have a few projects in this field, so this is one of them. It's more related to the infrastructure for the imaging analysis, but it's very much into the implementation between the two centers, Poznan and the site at Mikołajki in Poland, that will focus on the imaging research for the biology, and this is also part of the EMBL research infrastructure. One of the things I do in PSNC is try to coordinate effort in the open science. We recognize open science as an essential driver for the future, as an essential advancement of the future of the scientific processes. And we try to facilitate that with the innovative services and with the innovative technical capabilities. We work on the EOS core to develop, sorry.
Can I sit?
To develop AI-assisted recommendation system for the user interface, to develop something that is dedicated to the scientist, something that will help scientists to navigate through the open science resources. However, we also see all infrastructure projects, all that we do, as an enablers to the open science. And we think, when implementing the services in the projects, we think through this sort of fairness criteria, through the adaptability to EOS, but to advance the findability, accessibility, reusability, and interoperability. So that's your fairness of the services and the data the data storage that we are going to implement. We also work on the 5G, so that is one of the network projects that is in quite an advanced state at this stage. So it involves field trials and simulation of the 5G environment. So we've been working with the vendors of the simulation of the radio environment for 5G, and to provide the services to test the 5G devices in the various scenarios of the radio environment. Like we are able to simulate the environment of movement of the device, for example, to test movable devices, to test drones, and other devices that are highly mobile, that are not similar to the phones. And in this, but also it involves this project involves a field trial with the installation of the 5G base station and corresponding network infrastructure that is essential for the 5G technology and corresponding network services to test the capability of distributing the network resources and creating the network services based on slicing of the network, if you will. So this is the part of the this project is the part of the slices S3 roadmap project effort that we work on, and we implement this research in Poznan. Of the more advanced networking, I would like to mention the quantum communications infrastructure. What you see here in the map is a proposal for the quantum communications infrastructure in Poland. Currently, we have implemented the QKD quantum key distribution links in on the metro scale with 5 kilometer range, and on the international scale with the 60 kilometer range link between Czech Republic and Poland. However, we are working on implementing the link, if I may use the laser pointer. Here. We are working on implementing the link between Poznan and Warsaw with two trusted repeater sites for the quantum key distribution project, based on the national NLPQT project, and that is in this stage of implementing. But with this national QCI infrastructure, we will extend that, and we plan to also extend that to the international connections to Germany, to Slovakia, and to Lithuania. We are also coordinating the access for the Polish scientific community to the IBM quantum resources. We are the first IBM quantum hub in Central and Eastern Europe, but this is more related to the pure quantum computational resources, so that our scientists can get access to the latest advancements of quantum computers to test their algorithms. However, as the last thing, I want to show you one more item here, that this all infrastructure is not something that you can turn off very easily. So what we do also, we try to, in the light of the latest developments of the energy costs, we try to, it's not that we can save energy by turning off the supercomputers or network, but what we can do, we can install the additional sources of the energy. So we currently have 3 major projects coming up with the installation of the energy sources, which will meet at least significant percentage of our energy needs, of our current energy needs. So this 20 kilowatt, this is the yellow area here, it's operational, and you can see the data from this solar array here. These 3 are in the various stages of public procurement, and 2 here are in the stages of the project creation. So in order to build for the construction of this, you have to come with certain steps. So with that, I would like to thank you. My contact information is in the slides, and these slides will be shared. And if you have any questions, I think that we are slightly over time, but we can handle 1 or 2 questions. Yes, please. Could you?
Thank you very much for very interesting and informative talk. I am interested if, I didn't see there, it is very important for healthcare and molecular biology. If you have implemented in your supercomputing molecular dynamic simulation, which is very important for drug design and drug receptor interaction for a big complexity. If yes, can we get remote access for computing? And it will take, even for supercomputing, it takes quite a bit of time for, if you will go millisecond regime for big molecules, and how computing time will be done.
So regarding the particular kind of simulation, I'm not able to tell you that. To be honest, I do not know, because there are other teams who work on this. You will have presentation today on the collaboration with the healthcare specifically, but regarding the computational time on the supercomputers, you have to write the grant proposal, the request for the grant for the computational time, and then the committee, the scientific committee, will look at the publications, will look at whether you are eligible, or not eligible, and then they will work with you. So they will either contact you for additional information, grant the computational resources. I will bring you I would say we take that offline, and I will provide you the information necessary.
Thank you very much.
Yes, so thank you. I think that we are... One more question? Yeah. Yeah.
Thank you for your excellent presentation. You mentioned that you work on development of recommendation system for support researchers. My first question is that what will recommend this system for researchers? And second question is that in development of the system, do you have open data, or you use public data set? Thank you very much.
So we use data from the EOS portal. So we use the data on user actions, user profiles, and the available data. Essentially, we collect the data. We use that. So I don't think it's a public data set. But what we recommend will be the EOSC resources. So that includes publications, that includes the data sets. So based on the profile of the user, based on the information that we have from the user on the previous actions, that will prioritize the choices from the available resources.
Thank you very much. And Mr. Raimundas, I have one question, if possible. You mentioned about smart laboratory, smart city laboratory, and what kind of work have you implemented and get a good result in this, for example, in Poznan or in Poland? For example, smart building or transportation and etc.
It's okay. So first of all, it's more smart building. It's we have a laboratory for smart buildings in one of our sites. We have 4 sites in Poznan. We have the energy consumption of the setup, but we also work with the pollution on the streets. We model the flows of the air in streets to model the pollution levels based on traffic. So that's to provide this data to the city authorities to model the traffic flows in the city, to indicate the areas where the pollution could be higher, because in some cities you have narrow streets and tall buildings, and that produces the air flows that do not ventilate the pollution good enough. So we have models to work on that. Oh. Thank you.
Thank you very much, Mr. Thank you very much, Mr. Raimundas. And our second presenter, Mr. Juraj Bilic, he is Vice of Croatian Academic and Research Network.
Well, hello. Opa. My mobile phone almost fell. So. Well, now something completely different, I suppose. First, I want to thank you all for inviting us here. This is a great conference. And above all, I want to say that Baku is a beautiful city. Thank you for inviting us. I'm really, really inspired by the looks of your city, and I will recommend for everybody to come here and to see Baku. And now let's go to the conference part of mine. This is about artificial intelligence in education. The question here posed is, does AI dream of electric sheep? Some of you watched Blade Runner, but what we actually ask ourselves is, how is artificial intelligence going to influence the education system, students, pupils, teachers, and the education process? And now I'll say something about how and what European Commission is doing with artificial intelligence. As you can see, European Commission will invest billions in artificial intelligence. Almost all EU countries do have their artificial intelligence strategy, and Croatia, where I come from, is also developing one. One of the main things dealing with artificial intelligence in education is not really to say what kind of direction artificial intelligence should have, but actually to say what kind of ethics should be behind the use of artificial intelligence. One example, psychoprofiling. Of course, we cannot use artificial intelligence in education for psychoprofiling, no matter how much some private companies want to. So ethical guidelines regarding artificial intelligence are one of the key things that European Union and its member states are trying to address. If we look at in education, we could say there are two big fields of to apply artificial intelligence in education. Well, the second thing, in my opinion, is even more important, education on artificial intelligence. I will get back more to that later, but the thing I want to point out is that in the old Greece, the saying was that if you don't deal with politics, the politics will still deal with you, and that is why any sane person, wise person will deal with politics, because it will always deal with you. The same is with artificial intelligence. Even if you don't care about it, it will have a very significant impact on your life. And that is why it is important that pupils of today, which are rulers of tomorrow, know how artificial intelligence is going to influence them and the society as a whole. The other thing is more practical, more product-oriented, and it's use of artificial intelligence in problem-solving in the education sector. I will get back later more on that point. This is something my institution is also addressing. Well, here it is. Of course, everybody's talking about personalized learning. In the also old Greece, Alexander the Great had his own mentor. What we are trying to do now is through artificial intelligence, personalized learning in such a way that almost everybody has his own mentor in form of one very highly intelligent bot. But we'll see how it goes. We have then personalized testing. We have a learning determining the difficulty of the task based on students' achievement. And it's also a very tricky situation and slippery field. If you let artificial intelligence base your predictions of your attainment of educational goals on your previous attainments, it can become self-fulfilling prophecy. And that is why we in Carnet always think that the person that will make the decision is not a computer or an algorithm, but a person in charge, meaning teacher. Of course, there is self-assessment, comparison of students at the national level. These are more like deep analysis, learning analytics. This is something that our ministry is very keen on having, and Carnet has developed Delta, which is actually software. My colleague could say more about that, who is the deputy CEO working on that, which is a software that crunches all the big data we receive from the students and then sets information for ministry, for the school, for the teachers, for headmasters. Well, this is the question with the obvious answer. It is a threat. It's also an opportunity. So the way we deal with it, the way we approach artificial intelligence will, of course, determine the future. And indeed, the different approaches are by the public institutions, by the state governments, and different are by the private companies, which is absolutely normal. Private companies will always look for profit, and public institutions and the state should always look after the well-being of all of the population. So this is somewhere where we have to work together. Here are some links, as my previous speakers said. You will have the presentation on the website of the conference later, so please look at those. Are very interesting articles to read. So here are some of the high risks that were identified within artificial intelligence for the society. I will not read all of them. These are the ones that were, I think, they were determined by the European Commission or the working body on artificial intelligence. Few examples. You come to the bank, you want to take a loan so that you can buy a flat for your family. And yes, 50 years ago and 70 years ago, they will check your credit status. But imagine, and it happens in some countries, if they also take into consideration how many driving tickets you had because you were speeding with your car, how many, I don't know, how many times were you late for your job and stuff like that. And they get all that information. They say, oh, you are not a very good citizen. You cannot get a loan in the bank. And this is happening in some countries already. using super algorithms. So let's be very careful how we apply artificial intelligence in everyday life. I talked about the psychoprofiling, which is very dangerous if we apply to the students and we determine their career path, meaning their life for the future. Let's also be very wary of that. In European Commission, I don't think it is, in European Union, I don't think it is possible due to GDPR, but there will be attempts always for stuff like that. So let's keep in mind that we are dealing with personal lives. Well, I guess most of you watched the Minority Report by Steven Spielberg, and Tom Cruise was the main actor. So if law enforcement uses algorithms to determine if you are a person who are more likely to commit a crime, and they are already doing it, but if they do it on a mass scale for every citizen, then and use it as a tool to convict you, even before you committed a crime, that would also be a very dangerous thing. Of course, I'm now going back to a bit to Black Mirror, if you watched it, but if you have the ability, usually you will use that ability. Of course, AI can be biased. AI is still programmed by human beings. So obviously, we are biased. AI is just the product of us. The second recommendation I think is very important. We can go further now. Well, this is I think, yes, UNESCO's document on the challenges that artificial intelligence has on education system. AI bias is most talked about these days, dealing with how AI does not recognize actually it overrepresents one part of the population and other represents other parts of the population. So AI is, of course, still learning. I suggest all of you to go to DALL-E Mini, DALL/E Mini, which is, you can write any words inside. For example, you can write inside name of the famous footballer playing, shooting rockets on the moon. And you write art, photorealistic, and you will see what it will produce for you. So it is amazing. This is the free of charge version. If you pay, you get much better version, and then you can see what AI can do with any of our inputs. This is something that we at Carnet are now thinking about. How to motivate students to get acquainted with AI. As I already said, no matter if you ignore it, it will still have impact on your life. How to teach future generation what AI is so that they can make informed decision. And when I say AI, of course, it is a contested term, because in the wider terminology, it could also say mean super algorithms, not only AI per se. So why is it important that students know what AI and algorithms do? So, for example, when they go to any portal, to social media, do they know why they click and click time and time again the same type of stories? Then they will still do it, but if we teach them what algorithm behind this is, they will have some distance towards it and know, okay, I clicked 5 times the same stupid story, but I know now why I'm doing this, and that's important. So this is just a bit of context. Carnet is a public institution, Croatian Academic Research Network, in charge of digitalization of primary, secondary, and higher education in Croatia. We have, sorry, am I on time? Hello, am I on time? Okay, great. So, and we have just now completing the biggest investment in digitalization in schools in whole of Europe per country, per population, per school. We have obtained 217 million euros from European structural funds and digitalized all of our schools in Croatia, over 1,000 of them. Meaning we provided them infrastructure, laptops, Wi-Fi's, services, open education resources, education for teachers to implement all of those tools, e-services. But now we want to go a step further. And the step further is to introduce AI into school through systematic approach, by encouraging research into the application of AI in education, and of course through pilot example, because you never roll out a national project before piloting it. That's something you don't do. So I will now talk a bit about our project and what we are trying to do. For this project, we have received 15 million euros from European Social Fund. It's also a national project we are doing together with Ministry of Science and Education. We will develop a curricula about and for AI. What is the difference? Curricula about AI will be for all the students, all the pupils in primary and secondary schools, to teach them what I already said, how those algorithms work, how they impact your conscience, how they change your perception of the world. And for AI will be for those extra talented, so that they are the ones that can use AI in the future to change the world. So about is for all of the students, and for is for those best ones. So of course we will develop cross-curricular topics. We will also develop a 2-year subject for Croatian schools. And we will organize all those things that are mentioned here. Of course, before the curriculum, you have to develop a syllabus for the teachers and teach the teachers in order for them to be able to transfer this knowledge. So this is the purpose. The main purpose is develop digital literacy. And digital literacy is a relatively new term, meaning critical thinking in reading, observing with understanding in a digital online environment. I already talked about it. Digital literacy is just a form of literacy. It is not a special part. It is not a special ability. It is a form of how literate you are. But we need to make sure that our children, students, pupils, know what are they not only what they are reading, but why are they reading what they are reading. And it all comes then to what is, how is content curated, how can I fall into an echo chamber, and things like that. Okay, I'm almost finished. And the other thing is research on the application of AI among students. So we want to dissect algorithms behind social media networks, clickbaitism, for lack of better meaning, something that makes you click another same story, echo chambers, and various forms of content curating. And then this research will provide input to the curricula. So this goes hand in hand. The research will provide input to the curricula, and in that way we will update curricula after the first phase of research is finished. And of course, other stuff that are more technical, but I'm really now focusing on this educational and research part. We already established a research team and curricular team. It's part of the wider team investigating impact on ICT on students' mental, social, and physical health. I don't know if in Azerbaijan we conducted the big research on the impact of online education on Croatian students during the pandemics. They were not all the time in the homes. Most of the time they were in the school, thanks to our Ministry of Science. But however, for some months they were at home. The results are catastrophic. So online education cannot compete with traditional education. You should use ICT technology in class, not for online education, unless it's no other way. And okay, system for self-assessment, knowledge testing, that's something we have developing as a service, but I think it needs a special focus, so I will not now go into details, and anyway, I'm almost out of time. And so, this is the last slide, current status of the project. As I said, it's a complex and groundbreaking project. We were awarded 50 million euros, and we will be implementing it next year for 6 years. And submitting the project proposal will be on 17th of September. And we are hoping that the project will start officially, although some of the works already started by the March next year. Thank you very much.
Okay. Okay, thank you. Any questions? I will allow one question. So please handle the microphone.
Thank you very much. You have touched very important issues. In terms of application of artificial intelligence, outcome is also depend on model building. In order to share,
can you put the microphone?
In order to share and compare, let's say, assess our students' performance, do you think we should adopt same protocol or model? So
You think our model or?
Yeah, no, I mean across Europe, for example, because
I think I can answer you. I can answer your question. I think adopting the same model is always dangerous. What we should do, we should let a couple of member states and also non-member states like Azerbaijan try pilot something, and then we can get together in 2 or 3 years and see which is the best model. Let's not adopt the same model before we pilot a couple of them.
At some level, we should do that because we should understand how it works, and also so we can, because it depends, outcome depends on the model. So we want to be able to directly compare your model in our.
Absolutely, yes, yes. Okay. Let's have more models, compare, and then take the best pieces from each.
Thank you very much.
Thank you.
Thank you. Hvala, Juraj.
Thank
you. And could you please contact Professor Ramis offline? Thank you. So I would like to introduce the next speaker, Gianni Della Torre, from EGI Foundation in the Netherlands. Thank you.
Thank you.
What is yours?
So, good morning, everybody. May I have the slide, please? Yeah, thank you. Thank you for being here today. I also want to take a chance to thank the organization and for the conference and the Azerbaijan representative for hosting this truly inspiring event. I'm Gianni Della Torre, Cloud Computing Manager from the EGI Foundation, and I'm supporting the activities and delivery of the EGI cloud activities and community, contributing to several years when the EGI participated project. For me and for the EGI Federation, it is an authentic pleasure to be here today, and with my talk, I will give you an overview and share our experience in building a global science cloud community. I will start with a short overview of what EGI is, our mission, and how our federation provides value for the broad scientific community. Then I will give you some insight into the services and technology used to build our federation. Finally, I will conclude with a few details on our program to support the open science south of Europe. Starting with a little bit of history. In the early 90s, the international community of the physics of high energy came together to define a distributed IT compute infrastructure model, which allowed them to compute and store huge amounts of data coming from the Large Hadron Collider established at the CERN facility in Geneva. The idea of EGI grew out from that as a general model to apply to other disciplines scientific communities, and flash forward today, EGI is now supporting more than 215 communities, not only with grid model, but with a large portfolio or services that I will describe in more detail later. In 2010, EGI became a non-profit organization based in Amsterdam. And in few words, the vision of EGI is simple to provide seamless access to services, resource, and expertise. The EGI Federation is a pan-European infrastructure that supports a diverse set of disciplinary areas with the computing infrastructure that the scientists need to deal with the increasing amount of digital data produced in experiments and collected from sensors. The Federation is composed of infrastructure providers from national and community initiatives, forming one of the largest distributed computing infrastructure for research. For each country, there is a designated institute which represents the national community, and depending on the country organization, it may be dozens or even hundreds of institutes. and what we do. The vision of the European Commission with the European Open Science Cloud project is indeed really aligned with the vision of EGI. EOSC is a multi-project program which is supported by European Commission, the Member State, and the research community, and builds on existing infrastructure and services and brings them together in a federated manner. EGI has been playing a strong role in the development and delivery of the European Open Science Cloud since 2016, leading and participating in several EOSC-related projects like EOSC Pilot, EOSC Hub, EOSC Future, and EGIAs. EGIAs is a 30-month EGI flagship project funded by the European Commission to implement the EOSC Compute Platform. Today, I will present a few slides about EGIAs, as one of the tasks of the project is dedicated to international clouds. The goal of this task is to expand the cloud infrastructure offered by the project by federating new infrastructure provider using federated access and platform services. In this map, you can appreciate the composition of the consortium. And yeah, as you can see, 4 of the partners are in common with the Eastern Partnership. The architecture of the compute platform delivered in EGIAs builds on top of the existing infrastructure services, which are composed of public research clouds and high throughput and high performance computing. In the middle layer, we have the platform services, which are implementing the federation and offering cloud services to scientists and the IT experts. In the upper layer is composed of scientific services offered to and from scientific users, while on the left side, here, you see a set of common services that applies to all the layers. This slide summarizes the major community that EGI is serving with the EGIAs project and the composition of used resources assigned to each one of them. We support a set of diverse disciplinary areas, which includes finding new tools for diagnosis disease, such as epilepsies and brain tumors, the design of new framework to assess and reduce the risk of flooding, the development of practical nuclear fusion, and several others. We are supporting use cases from both small and large communities, and we have defined a process to onboard users and groups to help them in their journey to reach their scientific goals. As said, the onboarding process are different is the scale and the timeline of the engagement. Still, the overall goal is to support science in a sustainable way, and for doing that, we carefully evaluate the needs of our community and our providers and serve them with the most appropriate type of funding. Before diving down into the services offered by EGI, I will briefly show you a few graphs that should give you a better understanding of EGIA's of the EGIA's project impacts. And here you can see the number of the users and the use cases that have been supported in time. Here is the composition of the application for the open calls. This is the services that have been asked the most. And finally, the cloud uptake along the EOSC Hub and EGIA's project. It is interesting to note that the direct funding from local infrastructure doubled the SC funding. As anticipated, I will also give you a short overview of the service provided by AGI. The service for research provided by the AGI Federation, by the AGI Federated Cloud Providers and Data Centers, and they can be requested by everyone involved in academic research. They represent our main value proposition, and I will spend an additional slide on them. The service for the Federation composes our internal service catalog. This service enables individuals' data centers to be operated in a federated manner and can be integrated with the AGI Federation. The infrastructure is geographically distributed and includes hundreds of data centers worldwide, and these tools for coordination improve how we work together. The business service are dedicated to collaboration and support private entities, and our business engagement program is organized within the AGI in a digital innovation hub, a virtual space where companies and technical services providers meet to test before invest. It's a new service, and it is being publicly presented for the first time during the AGI conference last week in Prague. AGI delivers technical and support service at European and global scale, including high-throughput computing, cloud computing, storage, data management, consultancy, support, training, and co-development. What you see here in this slide is an overview of the service catalog for the scientific communities as it is today. It is continuously revised and updated to match the needs of our customer to stay on par with the technological trends. And I will move on, giving you some insight of our engagement plan outside of Europe. In the context of the early mentioned task for the international cloud in AGI-ACE, we have defined a subset of the services for research that we are promoting for easy integration between the AGI Federation and the resource providers. The focus with this selection is portability, aiming to achieve portability of user identities, scientific dataset, and scientific applications. The AGI Cloud Integration Program established a partnership with cloud providers to connect their cloud to 3 central services. The check-in. With check-in, national users can reuse their identity across EOSC. With Data Hub, national clouds can publish scientific dataset between EOSC and their cloud. And with Data Hub, national cloud can share scientific application and services in the form of virtual machine between EOSC and other clouds. Besides the technical integration, our cloud provider also share practices of user support, resource allocation, user feedback, communication, and dissemination. And to help the new cloud provider joining the EOS Cloud Platform, we have also developed a guideline available from the link on the top. With this slide, I would like to show a practical example of one of the many outcomes that can be achieved with the suggested model. Scientists can take advantage of the Data Hub platform to manage their dataset in one of the storage providers adhering to the federation. Then other users can use this data directly from the Jupyter App notebook, which is indeed integrated to these data sets. Okay, and both of the users are made available, and both of the services are made available through one of the pre-configured virtual machine images shared in AppDB. During the first 15 months of the AGI project, new cloud providers have been fully onboarded with the schema, China and South Africa. The national cloud providers of Hungary, Georgia, South Africa, China, as well as the commercial cloud providers of Open Telecom Cloud and Cloudflare are in the program from the start, while others joined more recently, so the progress is still in the early stage. But I want to underline that the task is unfounded, so the achieved integration really testify the willing of the national provider to join the federation, as they don't have any project obligation. And to be honest, I'm really excited to say that, to add that the networking of this conference has already put some contact between EGI, and we are in discussion with a couple of people to see if we can also have Azerbaijan in the future. Oops, sorry, I was showing the wrong slide. So that's the status of the update. Different country. I'm also proud to say that the GI is bringing on several activities to support Ukrainian researchers, and during the last EGI conference there was a dedicated session to support Ukraine. Among the others, EGI will open its infrastructure to support Ukrainian scientific community. EGI, as we said, is not only about technical service. In the context of the training activity, I want to share some details about the Black Sun University Summer School that has been organized in September under the framework of the Memorandum of Understanding between BSAN and EGI. The school was held in Bucharest, and it was addressed to Masters of Science and PhD students from the Black Sea University Network and members of the service provider from a university and research institute interested in federating services and resources with EGI and the European Open Science Cloud. During the school, 6 new proof of concept and pilot use cases have been discussed, and they will be now submitted as an EGIA school, with few of them that have been already approved. So, oops. That is my last slide. I will just leave you with the benefit that we envisage for the scientific user community and the IT resource provider in adhering EOSC, the EOS Cloud Platform. And indeed, it's in the DNA of AGI to foster collaboration.
Yep. Thank you. Thank you. Grazie a tutti. And I would skip the questions. I would invite participants to catch Gianni at the coffee break during the lunch and to talk to him offline. So I would like to end the session. Thank you for listening to us, and please welcome the next session on the Earth observation.